So today I will start my course about design by according to Russian structures, Russian standards, Russian code. Uh, Excuse me. Uh-huh. According to Russian code, and I will start from the beginning. It's my topic will start from uh, type of our documentation. And after I think half of this presentation, I will start to explain about representation of drawings, and mostly it will concern of steel structures. But anyway, I think it will be useful for everybody because anyway, every engineers need to be uh, it's needed to be sure how to correctly read steel design drawings. So let's start. Here I represent stages of our documentation. So every project starts from pre-project documentation or project documentation. It depends on the size of project. If we have huge project like Preobrazhenskaya we are doing now, or other big project which must contain a lot of information and could not be covered by one stage, then usually client wants to create first pre-project documentation, which is closer to sketch documentation, let's say, and cover it with LOD level of development, which is mentioned in uh, American, mostly American document level of development. And this level of detailing is about 150, 200, and maximum when we see as built is 500. So I think it's something about 20% of full detailing which project can content of. So next stage is project documentation. It's about 200, 300 lot. Working documentation. Uh, Next one is fabrication detail drawings and layouts, which we call KMD in Russia. It's a Russian abbreviation, and as-built documentation. And it should be mentioned that every project stage must consist of minimum, but in the same time it should be necessary minimum volume of information, but in the same time this stage must be enough to make next one. I mean, for example, if we uh, have main, let's say, lines or shapes here, the same shapes should be mentioned here, and but with bigger and accurate detalization. So it goes from top to until the as-built documentation. But in the same time, I want to say that in usual scope of project uh, companies, we are dealing usually with PD, VD, and KMD drawings, which are the main scope of all this project. And in next slides, I will explain mostly about these three stages. And let's start from modeling and how we should design all these details inside of Tekla model or Revit model or other BIM systems. So for uh, here I show on the first row project documentation and pre-project documentation. The second row, the second column, we have working documentation and KMD documentation, which is mostly covered also as built. stage is on the third column, and the biggest uh, uh, difference is that on the first column, it's project documentation. We don't have joint at all. On second column, we have joint with all details, but usually in all the biggest difference between working documentation and KMD documentation in model, it's detailing, and detailing in very small very small details such as wells, bevels, and etc. So shape should be usually in working documentation should be corresponding to KMD stage. Okay, it's here I showed erection joint of beam and openings. Let's look at another types of details. Beam-to-beam connection, pin connection, also in working documentation and in KMD documentation, there are no big differences except I think wells, which are not represented here because they are miserable, and in project documentation we have no such joint details. Truss joint details, bracing connection the same. This is stud bolts connection, of course, in pre-project documentation. We don't have them at all. In working documentation, it's up to designer. In some cases, for example, if we need to design joint details for drawings, we should draw them, but usually we don't draw it. In KMD stage, we must show them all. And column to beam to column connection, usual one. Pin connection of brace with high strengthening bolts and rigid connection. So main idea, as I said before, is just project documentation. Usually, model of project documentation has no, almost have no joint details. Working documentation have details, but in the same time, they should not be 100% modeling in our model. I mean, for example, that we should model only the details which we are showing on drawings. For drawings, we can draw these details. For other, it's up to client. If clients want to increase working scope and are able to pay for this and for additional work hours, then we can do 100%. But in the same time, it's not necessary, for example, to fix all small issues. For example, we have beam and this beam connected in plane, and this beam connected in plane with different angles, two beams. So these details, for example, this horizontal beam will be changed a bit according to position of this beam. So in my mind, if we do the same joint details with small clashes, it could be okay for working documentation because we need to make model for another disciplines such as architectural department, mechanical, electrical, and so on. But for KMD, we should fix all these clashes, and our model must be perfect for manufacturing. And here we have base joint details, the same issue, and stiffeners. Also nothing specific. And joint detail of brace. And now let's speak about project documentation. And the most important things I need to mention for your knowledge. So first of all is that project documentation is the only stage of project which must pass let's called expertise in Russian government department. And in Russia we have two different types of expertise. Both of them are they are government, but one of them are no, One of them is government, another one is licensed by government, but actually it's like a private company. And the biggest difference of this expertises is that government expertise is more accurate and stricted, and it's harder to pass this expertise. And this expertise is must have to be done for all unique projects, for all hazardous project facilities, for all dangerous projects, and projects which are uh, paid by government money. For example, if we have now project where from all uh, from all price of project 10% is government money. In this case, we must go to government expertise. But in the same case, if we have no such requirements, such as a unique project and all dangerous things, which is specified by link below, then we can go to non-state expertise, and it's easy to pass it. It not decreased our scope, but in the same time, we can, for example, give pre-project, not finished yet project to this not state expertise, and they will give us comments before we enter to this expertise. So we can agree about issues before we enter. So it's more comfortable way to go to expertise in non-state. So I would suggest everyone to use this way if we can. Second point which should be mentioned is that project documentation consists of chapters on disciplines, such as structural chapter, uh, which is steel plus concrete, text part of this, graphical part, and calculation report. Actually, chapter, it's like in all this project documentation, is like let's call it book. This book consists of chapters, structural, and a lot of other like ventilation, mechanical. I think there are more than 30 different things, ecological things, but we are talking about construction parts, and usually they are represented by structural and architectural chapters. Third point is that in PD we should not show all secondary load bearing structures. I mean, for example, if we have fencing, non-bearing panels, small platforms, it's not necessary to show in project documentation. We should consider them in calculation, of course, but it's not necessary to draw them inside of this. And also, I want to warn you that our the main idea of all different this project, that we should provide minimum information in this project, but necessary volume to make next stage of this project. So we should not, if for example our secondary structures are affect somehow on another structures, so it's better to draw them at least, for example, in single lines. Very simple representation, but in this case we will warn next designers that we have something here, and he will know that it should take into account. And let's talk about text part of project documentation. As I shown here, text part is content of general data. Usually it's all this data written in A4 format of sheet, and it in this general data we have all initial data, all climatic loads, all information about region, all limits for our structural issues. So it's all general, all notes about our project. You most probably familiar with this. Also, we must show their load table according to which load we design our project. And at this point, expertise are is very important point for expertise because it corresponding to calculation reports also which we must provide to expertise. So I should point on this. And material specification. And material specification actually should not be represented in such complicated way. Actually, in many cases, I would recommend to write just total weight. For example, we make point in one point of general data and put there that all steel weight is, for example, 40,000 tons, something like this. And this is more than enough for next stage because when somebody will take a job for working documentation after project documentation, they will be informed that scope of work is this number of tons, and he can calculate estimates for this project. Sometimes, of course, client wants this kind of table, but on the first step, I would recommend just put number. That's it. Mm, about graphical parts, I would say that we have plans, usual plans, sections, but in the same time, we shouldn't write all sections we have. I mean, for example, if we have this kind of building, we can give 2 or 3 different sections, section view, and this more than enough for this kind of project. It's not a working documentation and not KMD documentation. So we need to show only idea of this project. And in the end of project documentation, we have joints. And usually I would recommend for not too big project, use 5 or maybe 7 joint details. And they should be typical, I mean, for let's say 30%, which are covered 30% of all joint details. And this is enough for project documentation, for understanding of working documentation designer, what will be included in his scope. And in the end of our project documentation, we must provide calculation reports, which will be provided also to expertise for their check. And these calculation reports consist of initial information similar to general text notes of project documentation with all loads, climatic regions, and so on and so forth. Also, we should represent finite element model, how we calculate, and also diagrams. And in the end, we provide calculation of the most typical elements and most loaded elements. And in the end, we should write conclusion, where we write that everything is fine, as always, of course. And after this, usual certificates about programs. Now we will speak about working documentation. And this is the main points about this. Work documentation, as you understand, must be similar to project documentation. And if we change project in working documentation something very small, small elements, we must be sure that we not reduce bearing capacity of elements, because if we decrease some elements and bearing capacity, in this case it will be basement to go back and changing of project documentation and need to go to expertise second time. I would not recommend this because this costs additional money, not small money. Working hours, it takes few months usually. So I would recommend to take project documentation, and if you are recalculating this documentation, you can just increase sections, not decrease. And also we should not change working system of building structures. For example, if in project documentation we have braces, we should not delete them, as I told before, because it will lead to necessity to go again to expertise. It's not need to anyone. And difference between project documentation is that working documentation, as you know, consists of a set of drawings. It's not chapters as in book. It's just usual drawing sets. And working documentation must contain all load-bearing secondary structures, such as Fachwerk, mm, uh, secondary platforms, everything. All structures must be represented in this documentation. And in working documentation, we should not develop 100% of joint details. This is one of the biggest, I would not say it's mistake of design groups, but they spend extra time for design 100% of joint details. But actually, in most cases, it's not necessary. It's necessary. We need to design in model at least the most important joint details. For example, 70-80% of all joint details. Make for them drawings, and all other 20% which are not too much loaded could be designed by KMG designers. In this case, we can save a lot of working hours of our teams for modeling, because we don't need to copy all these details, and in the same time we save hours for drawing details, because 20% is also sometimes very crucial. And what is working documentation according to its content? So drawing set usually content of general data with more or less short, at least it's shorter than in project documentation, general notes about design. And this notes usually more detailed according to numbers of bolts, classes of bolts, materials, profiles, and so on, etc. Additional tables, I will explain it, I think, in next course. Steel specification according to GOST. This is very restricted here. Layouts, we have full pack of layouts, which is necessary for KMD drawings, because as I told before, we should provide all information for KMG. KMG should not design anything except maybe some of the joint details. And the section views also, we have full pack of them. And joint details, they are more than in project details. And let's compare project documentation and working documentation. Both of them are contain general data, both of them contents material list, but in this case, in project documentation, we can short this to just one number of total weight. And also in project documentation, we have additional load table, which is not represented in working documentation, because in working documentation, we are recalculating this sometimes if we did if, for example, project documentation was calculated by another company. In working documentation, usually it's needed to recalculate because you are taking responsibility about this project. But if you already calculate this project, you don't need to deal with loads at all. You already have on working documentation all information about loads and full calculation model. Also, in working documentation, we don't need calculation report, and we have less text description in general data than in project documentation. But let's say this text description contains more detailed information about procedure of construction, but here is more general information about all project allocation. What about drawings? In both cases, we have layouts, we have sections with different quantities, and also we have joint details with as well different quantities. But in first case, we must pass expertise, but and in another case, we have more detailed project. And now let's talk about drawing representation. In Russia, we have two types of drawing representation. One of them is represented in simple lines. In Tekla, it calls reference lines, like center lines. This comes from, I think, Soviet Union, when people don't want to draw squares, and they replace it with simple lines. And for section view, these sections anyway, beams are represented in contour shape, but braces, some kind of horizontal braces, they are anyway represented in lines. So everything, for example, here for level marks, we must represent in full shape. And second option is contour lines. It's usual contour shape of detail. If we are working in 3D model, I would recommend to choose this one, but not be surprised that if you get drawings in this kind of representation, because most of Russian engineers would prefer to take this one actually. And next slide is about complex assembly marks. For example, we have truss, usual truss, and this truss has a side joint in the middle. And there are two options how to mark this truss in steel design, steel project. We can divide this truss for two marks and call them F1 and F2, or we can mark all this truss as F1. And in both of cases, we will get one section view. For example, if let it be not section view, let it be layout of this truss where I want to mark all this section. And in this case, I say that I name this view as section view or geometry scheme of F1 and F2 marks, because every mark acts as single mark. And in this way, I will name them as common, one uniform mark. And according to working and project documentation stage, we should name these marks in KMD similar to marks in working and project documentation. For example, if we have F1 here, we should add additional postfix here to make this mark unique. For example, we have two marks different. One of this mark has some plates in this connection. Another one doesn't have this connection. I mean, strengthening of these joint details. So in this case, one mark will be F1-1 and second mark will be F1-2. So it will be like their ID number, but this number should be corresponded with working documentation and project documentation numbering mark. And yeah, and here we can show, for example, if we divide this mark for two different assemblies in KMG, we will represent this mark as separate mark, and one part will be F1-1, another one will be F1, F2-1. But here it will be different. Start beginning of the mark will be the same, but unique number will be different. So after this presentation, actually you can look at this slide more accurate, and it's not so hard to understand all this logic actually. And in KM documentation, working documentation and project documentation, we have one of the most complicated table for filling. It's called element list according to their mark. So in first row we have mark of element like such as F1, for example. This is sketch of this mark's position. If, for example, in this case, our mark content of two channel profile, which is connected with each other with plate. And another example is welded I-beam. Also, this is position of element, so it's easy to understand what kind of section is it. And support forces. It's very important to understand that this is not maximum forces in our element. It's not moment in the beginning of, in the middle of pin connection beam, because it's totally not correct. It's support. Let's call it reactions, which should be considered when KMD designer or KM designer start to calculate joint detail. For example, we have B1 I-beam. I write here for that shear force will be 40 kilonewtons and moment connection 5 kilonewton meter. It means that when one person made calculation model and write that all beams which has this section should be connected to these forces, it means that this more than enough information to create a joint connection, because joint designer will get a project with section according to this table and forces. So it's more than enough to be able to calculate and design correct joint details. Be careful about this. Next column is material and nodes. And also in the end of table, usually we mark complicated complex sections such as F1 truss. We talked on the previous slide. If, for example, we have complicated complex assembly, we can mark that we have in drawing set, we have this F1 assembly. We can say that this assembly, a geometry scheme of this assembly, you can see on number of list 9, and on this list we should draw this kind of scheme. I marked with dashed different areas for your understanding, but this is not we don't need to use these areas for real drawing, so it's just for your understanding. This is usual truss scheme F1 or F1 or F1 plus F2, doesn't matter. And on this geometry scheme, we must show all sections, this one, this one, this one, and this one, and forces. If we have symmetrical geometry as here, except side joint. So if we do not consider this side joint, then our geometry is totally symmetric. In this case, in half of this truss, we can write sections and materials for elements. On another side, we can write forces in this truss and support reactions. If we have not symmetrical section, we should draw this scheme twice, for example, and call it this is geometrical section F1, and write that here I show only section, and on the second one will be written that I shown only internal forces in this. These forces needed also to design and check all details for punching, for welding, for everything. And these forces also are very important reactions, excuse me, because when person will start to design this drawing, joint detail, he must be able to do it without getting calculation from the beginning. And also on this kind of drawings, we must show all strengthening if we need it, and typical joint details for working documentation. And I want to add one more note about complex structures. It's not only about trusses. It could be double short vertical columns where with crane parts and also diagonals. It could be what else? It could be different part of complex elements, but usually it's cones. They are cones and trusses. Let's go further. Here I will start to discuss about welding symbols. This is an example how this welding should be represented, and short legend about marks, welding marks. This mark ЧПП means in Russian full penetration weld, and we can mark it as here, as near. Also we can write it near to welding for understanding. This means contour welding. For example, here we can add this 8 millimeters in square. It will mean that all this welding on the contour should be 8 millimeters diameter or 16 millimeters, doesn't matter. And this sign is for calculation length of weld. For example, I calculate this brace for 20 or 50 kilonewtons. and this length must be 280 millimeters. I should write and 8 millimeters leg of weld. I should write here 8-300. It means that I calculated for 280 millimeters length plus 20 millimeters, which are not working in the, because first 10 millimeters and 10 millimeters are not working in bearing capacity of this weld. So I can mark this welding in this way. If I calculate it, and it's very important to, and it should not be decreased in KMD working in KMD documentation. And here a specific line, here is represented specific lines for welding. These are visible welding, this is hidden welding, as here, for example, here, invisible welding, but in order to do not show this welding from, for example, top side, in order to do not draw additional view to show this welding, I can leave it like this and draw this kind of welding, and everybody will understand that over this opposite to this plate, over this plate, I have welding. This how to represent from profile view and full penetration welds. And in the end, I want to discuss about other symbols. For example, this symbol we use for side joint details in columns, in trusses usually, sometimes in beams. It's very uniform symbol. This bolt is for assembling, bolt for just for assembling. It means that this is not a bearing bolt, it's just for installation. This is the most useful bolt, permanent bolt with accuracy class B. This high strength bolt, usually with pretension. If you don't use pretension or use pretension, we should mark it in general notes. This symbol is for support of monorail. If we have monorail from plan, we can, on the plan, if this monorail connected to some kind of beam on plan, we can mark this place with such symbol. This intermediate monorail support. And the last one important symbol is symbol which is used for nearest building. As an example, I can say that we are creating block A of some kind of building, and if we have block B and do not show this block B in our drawing, we can draw one axis of this block B as reference axis, and we can do it in this way. So it was the first part of my lecture. Thank you for your attention, and I'm waiting for your question, if you have so. If not, will anybody ask? Okay, Miraj, you can start.
My question about project documentation and working documentation calculation. At project documentation, some company or some engineers calculate and responsible for the project. On the other way, working documentation we can calculate again. But who is responsible for this case?
I think that this responsibility is very smooth because usually the person who pass expertise, he is responsible. In the same case, nobody knows about responsibility of expertise about this project. I think that if accident will happen, everybody will be punished. But this importance of this punishment, I don't know who will deal with this. I think it's the some special department in Russia will care about this. In my mind, everybody should be responsible on their work. For example, if I must do working documentation and project documentation was issued by another person, another company, I will definitely recalculate their model because if their model is incorrect or mm, some structures will not carry load, I also will be partially responsible about this project. So I would suggest anyway recalculate others models. You're welcome.